Programs often need to make decisions to do one thing if a condition is true and something else if it's false. So in Python, decision making is done using control structures like if, elif, and else. Let's start with the basic structure of an if statement. So you write if and then condition. So you can see the if condition block. So you write if keyword and then condition comes, then colon, and then one tab indented statements. Remember, Python uses indentation instead of curly braces to define blocks of code. Usually we indent by 4 spaces. When you enter a value, Python checks the condition age is greater than is equals to 18. If it is true, it prints you are adult, otherwise the else block runs. We can also chain multiple conditions using elif, short for else if. For example, Python checks each condition from top to bottom and executes the first one that is true, then skips the rest. This makes control structures powerful and easy to read, one of the reasons Python is famous for its clarity. In this example, if you enter 82, the first condition marks is greater than equals to 90 is false. So Python moves on to the next condition, that is marks greater than is equals to 75. That is true, so it prints grade B and skips all the remaining checks. Operators in Python lets you manipulate data from simple math to logical decisions and bit level manipulation. So let's take a quick tour to now let's take an overview of Python's main operators grouped by their purpose. On the left, we begin with the arithmetic operators. These handle basic mathematical operations. The plus sign performs addition, the minus sign is for subtraction, asterisk is for multiplication, and forward slash for division, which always produces a floating point result. Percent sign gives the modulus or remainder of a division. The double asterisk represent exponentiation, such as x double asterisk y means x raised to the power of y. Finally, double slash performs floor division, which rounds the quotient down to the nearest whole number. Moving to the top right, we have a comparison operators. These compare values and return either true or false. Double equals to checks for equality and not equals to checks for inequality. We use greater and less than signs for checking equivalently less than or greater than conditions, and then less than equals or greater than equals when we want to include the equality in the comparison. So these are very common in conditions and loops. Now let's look at the logical operators table. The word and returns true if both the conditions are true, and the keyword or returns true if even one condition is true, and not simply reverses a condition. If something is true, not makes it false, and if something is false, then not makes it true. Finally, we have an identity operator, that is and is not. These check whether two names actually refer to the same object in the memory, not just equal values. For example, x is y returns true if both variables point to the same object. X is not y returns true when they refer to different objects. So in summary, Python operators help us perform calculations, comparison, and logical tests efficiently, and understanding which operator to use and when is a key to write clear and bug-free code. Python arithmetic is very intuitive, always performs true division and returns a float. In Python, there are three closely related division operations. The single slash performs true division, so it always returns a floating point result. Double slash is called floor division. It divides two numbers but then rounds down to the nearest integer, not simply truncating the decimal part. This difference is especially noticeable when we use or deal with negative numbers. For example, minus 3 double slash 2 gives us minus 2, not minus 1. Because Python's floor division always rounds down towards negative infinity. The modulus operator gives the remainder of the division. In Python, it is defined so that this formula always holds. So for minus 3 modulus operator 2, the result is 1. Since minus 3 equals to minus 2 into 2 plus 1. So this consistent rule is what makes division and remainder behave logically across both positive and negative numbers. Python sequence operators make working with strings and lists very intuitive. The plus signs joins sequences together. This is called concatenation. When we write hello plus world, Python builds a brand new string containing both. The originals stay the same because strings are immutable. So we will see what is immutable and mutable data structures in a moment, or objects in a moment. List also support plus, like if we plus two lists, one containing 1 comma 2 and second one as 3 comma 4, this gives us a new list 1 2 3 4. This is handy for merging data, but keep in mind it doesn't modify either list. It creates a new one. The asterisk is a repetition operator. Here the string HA into 3 gives this string. For list, subscript of 0 into 4 creates 4 zeros. However, repetition can be tricky with mutable elements. For example, if you repeat a list that contains another list, then the Python reuses the same reference. Appending to one sublist will change all of them. This is because the repetition duplicates the references, not the deep copies of the content. So the rule of thumb is plus and asterisk with sequences always return a new object, but the contents inside may still be shared if they are immutable. Understanding that distinction is essential when manipulating lists in Python.